All right, hello everyone, welcome to the video. This is going to be a conceptual problem about a bimetallic strip object. So one of the things that is interesting about thermal expansion is that different materials have different coefficients of thermal expansion. They change length by different amounts when they undergo a certain change in temperature. So I have a table of values here I wanted to show you. Let's start off with one of the higher ones on the list, which is the material, the metal, known as lead. It will actually have a coefficient of thermal expansion of 29 times 10 to the minus 6 inverse Celsius degrees. Okay, so there's one value. Another relatively high one is for aluminum. That is going to be 23 times 10 to the minus 6 inverse Celsius degrees. And then we can go down a little bit to brass and copper. So here's brass, here's copper, and brass is going to have 19 times 10 to the minus 6 inverse degrees Celsius. Copper is 17 times 10 to the minus 6 inverse degrees Celsius. Just for fun, we can also go down to a few other ones. So here is iron. Iron is only going to be 12 times 10 to the minus 6 inverse degrees Celsius. And we can go to even some non-metals just to show you. So if you took typical glass or soda lime glass, this is going to be 8.5 times 10 to the minus 6. Big jump there down to 8.5. And how about even diamond? If you could find a nice large piece of diamond and do some careful measurements, you would find that it's only 1 times 10 to the minus 6 inverse degrees Celsius. So we can see that our nice ductile metals are going to ironically also have lots of potential for thermal expansion. They have a higher coefficient of thermal expansion, and these more brittle nonmetals like glass and diamond will not be having as much thermal expansion. All right, so what we want to think about is if we constructed a object that had two thin pieces of material laminated together, glued together like this. One is we have material 1 and material 2. What will happen to this when it gets heated up if material 1 and material 2 are two different materials, two different metals from our list? So just for completeness, we could imagine one is iron and one is copper, let's say. What's going to happen to the bimetallic strip when we heat it up? One side is iron, one side is copper. So what we need to do is imagine some different cases. So if we have, say, the iron strip and the copper strip. The iron has a smaller coefficient of thermal expansion than the copper. The copper has a larger one, 17 and 12 in these units. So when you heat it up, the copper one is going to get larger. Let's imagine just as like a thought experiment, they're both going to get longer, but the copper is going to get longer by more. So we can imagine, here's the line that was their initial length. We can see that the iron has increased in length by a little bit, but the copper has increased by even more. And this was the bottoms of them. So how can I have these two pieces have different changes of length but actually still stay laminated together? Remember, this side here is a glue joint. I only separated them here just to visualize it. The answer is that they're going to have to curve. So we can have the iron one going like this, and we're going to have the copper one on the outside going like this. By going in a curve, we are essentially having a greater circumferential length because the iron one is essentially having like a smaller radius. So we could imagine having a radius here, a radius for the iron, and we could imagine having a radius for the copper, and then we're basically tracing out little parts of a circle here. So as you know, the circumference of a circle is 2 pi r, so you're going to have a greater length, greater arc length here on a circle with a larger radius than you will on one with a smaller radius. And so that's how we accommodate the different change of length, by just having them be curved segments on different radii circles, essentially. Okay, so one way to just kind of take this all in is that the bimetallic strip is going to bend towards the side with the smaller coefficient of thermal expansion. All right, if we had reversed the position of the iron and the copper, then the strip would have curved the other way, in fact. So that, everyone, is the behavior of the bimetallic strip. This used to be used in analog thermostats. If you had a device like this connected to like a lever system, you could have some activation of heating system of a house when this curvature has reached a certain preset value. Of course, now thermostats are controlled using a different form of temperature sensing, but this is one older fashioned way of doing it. Okay, thanks everyone for watching, and I'll see you in the next video.